Great. I guess why don't we go ahead, let's get started, a little ahead of schedule, but with re:Invent, a lot of things to kind of go to, places to get to. So first of all, we'd like to thank you for taking the time to come in and learn about edge computing. Both Joseph and I will be presenting today, kind of give you an overview on edge computing, business side of it, how do you apply it, where it makes sense. So as you guys, again, a lot of folks in the room here are partners, looking at your practice, how do you develop in terms of maybe new capabilities within your organization. So with that, I'll turn over to Joseph. Introduce yourself.
Hi, my name is also Joseph. I'm a colleague of Joseph Soloker. I run the global partner ecosystem for industrial software in a vertical, meaning all software partners that produce software for product design, and production. Within production, we have all the systems from industrial controls up to human-machine interfaces, up to manufacturing execution systems, and industrial IoT applications where we do closely collaborate with, so that you just know why we're speaking here. So first, a quick introduction into edge computing. Why? Why do we need edge computing? The advent of cloud computing has enabled a broad variety of applications that never have been possible before. All those virtual machines, all the compute, all the storage that is now available at a very good cost point allows us to do incredible things. And naturally, all those applications generate needs for having better applications, artificial intelligence applications, and so on. Also, in new types of use cases, closer to the physical things, yeah? Like in autonomous driving and so on. So just to give you an example, if I would be driving in an autonomous car and there is a deer in front of the road coming there, no one wants to wait until the car has connected to the cloud, the algorithm has derived which way around the deer, and then pushed it back to the actuators in the car. And therefore, we need to have a new model where compute, as far as it is required, is more closer to the actual thing, produces processing the massive amounts of data generated by the world of Internet of Things. Good. First of all, before we start, a quick slide on the definitions. I think this is important because it very often gets mixed up. The first thing is cloud, everyone knows it. These are typically enterprise applications that take up to minutes in response time. I know it is much quicker, but the required response time is not so fast. And then there is fog computing. Fog computing was coined by Cisco, and it's basically pushing down compute and storage to the local network, to routers and switches and so on. With this, we can limit the latency from a local side to the cloud, but we still have the latency from the local side to the thing. Edge computing really means putting small processors that can efficiently communicate with the cloud to the thing itself, to the healthcare device, to the industrial control and what have you, to really go into the milliseconds up to nanoseconds of response time, depending on the process that requires this. So what are the business drivers? First of all, bandwidth is not always cheap. Just think of an oil rig. Oil rigs out in the North Sea, for example. You build up own transmission lines and connections. These are very expensive. And it needs to be ensured that only data that needs to be transferred is really transferred over these very costly lines. Lack of connectivity, as with the autonomous car example, it's not always ensured that there is always connectivity to the internet for any type of application that needs to sit close to the physical world. Also true, for example, for manufacturing sites in countries where there is often power outages, and there is a couple of them around the world. Real-time decisions, just mentioned, we can get down to the nanosecond level, and security and privacy. Once you have an application that really handles your core data, makes predictions on assets, is influencing your ability to steer a vehicle, to keep up production line, you don't want to have any security threat to it.
Hey, Joseph, let me just add a little something. So again, as you guys as partners who are out there, you have a lot of your customers are coming to you. They're looking to do different things, very, very unique, driving the art of possible. Edge computing is something that we're seeing an emerging trend kind of in the space, pushing intelligence further down, if you will. One of the things as you kind of look at it to be able to test, whether or not edge computing is a fit, the attributes that we have kind of showing here on the screen are really a really nice way for you as a partner to really test your customer's need and whether or not edge computing, fits from a business driver perspective. So if any of these attributes, are present with respect to your customers, what they're asking, what they're looking for, then edge compute will probably be a good fit.
Very good, thank you. So what are the benefits? As I said, you can quickly respond to local events. Latency can go down to a large degree, even to the nanosecond level. Operating offline, we have already generated use cases, demonstrators with real industrial equipment. I'll show you later a small video where that is possible, where you can control in a local loop and can unplug it from the internet and replug it in and still works. For the status it has before it was unplugged. And then simplified programming. This is an interesting thing because there is already microprocessors everywhere in the physical world. The interesting thing is just they are not all programmable at all, and then they are programmable in totally different languages and not in real in the languages the modern IT folks want to program into, like Python or C++ and whatever. With edge computing, you can have your code, your algorithms in the cloud. Whenever an edge device connects to the cloud, it gets the latest version of the code with the latest optimization, and you at the same time always have a full representation of all code that's executed at the edge in the cloud. Tremendous benefit. TCO, as I already said, bandwidth, all other things, sometimes are very restricted. With thoughtful edge architecture, it's possible to really optimize the cost and have compute there where it's needed at the edge, typically a bit more costly than in the cloud. And then as lower the requirements on latency are, you can push it further to the cloud and make use of all the innovation, all the compute power you have in the cloud. And finally, security. And I can speak from my partner ecosystem for the industrials. A lot of reasons why customers talk to us, partners talk to us, is because they want to make sure that they have all their application within one security concept. AWS allows you to have all the mechanisms, encryption of data at rest and in motion, all the certification, certificate handover and so on, down to the edge and have one security concept applied.
So well, maybe before we move on, I got a question maybe, because we got a lot of partners here in the room. So with respect to edge computing, maybe just a show of hands, how many people are kind of working in the space? How many people are getting requests for the space? Get us a feel in terms of maybe the audience, in terms of the, so it looks like a fair number of folks are starting to engage. Would anybody actually want to stand up, introduce yourself, your company name, and maybe tell maybe something specific about an edge case you're doing? You don't need to name the customer name, but would anybody want to share anything that they're doing? Shubho. Huh? Microphone.
Yeah, hello, I'm Shubho, and I represent Addison. And we've done this implementation with a major mobile provider in Europe for a POC on autonomous cars. Okay. So we had done a demo of sorts where we had used edge compute to ensure that all the transactions are done at the edge. Where the latency has to be very low and so on and so forth. So you're going to keep Joseph from hitting that deer on the road on the Autobahn then?
Yeah, thank you.
Yeah.
Awesome.
Yeah.
Thank you, Shubho.
Thank you.
I'm Peter Bourne. I'm with Brightwolf. We've done several edge implementations, some in healthcare where you have to separate data using some compute at the edge based on personally identifiable information and PHI as well. So for regulatory requirements and security. Also in environments where, which maybe regulatory I don't think was a thing up there, but could be. Yep. Also in environments where the bandwidth is restricted, and Joseph, you mentioned HMIs in your preamble, and so in some cases the HMIs that are IoT attached are very compute restricted. and require local, very network restricted and require local compute capabilities. Just a couple of examples.
Excellent. Thanks, Peter. Jerome? Sure, absolutely. We got a little bit of time.
Jerome Chang with NXP Semiconductor. So we've been partnering with Amazon and Brightwolf for the same reason. A lot of regulation, like the GDPR regulation in Europe, trying to provide some data protection profile, makes us realize that there is not a single node that is too small for this kind of infrastructure. And so with this, as you scale down, you do realize that the power performance of some architectures provide you with a step function in terms of power and horsepower consumption. At this point in time, we're working with telcos to understand how we can better serve those specific needs at the end. And so what we see fit, for example, in terms of operations for security and for computer vision is the sanitization of the data at the point of measurements in places where some specific captures for video, for example, allows you to extract some semantics out of it and then minimize the bandwidth going up to the cloud. These are typical applications that we see fit and tremendous requirement for both security and low power computing.
Awesome. Thanks, Jerome. Thanks, everybody. Yeah. Joseph.
Thank you. Good. So now that we know why do we edge computing, what the benefits are, the question is what is the addressable market, and we have some figures with you. Let me start with a concrete example of an oil rig. Oil rig typically, on average, generates 500 gigabyte per data per week, but only 1% is transferred to the land for further analytics. So the funny thing with analytics is you don't know what you don't know. So you don't know which data you should, which data points will be essential for your future findings to generate some value. With edge compute, you can do some pre-processing, like for example, do image recognition, just transfer the object you've seen in an image instead of transferring the full image, making best use of your bandwidth, but have all the data in the cloud for further analytics. So what you can see here is purely from a data angle, there's a lot of opportunity that's currently uncaptured. If we look at different verticals, what we clearly see is that all types of verticals are seen to have significant potential for edge computing. Two really stand out. The one thing is autonomous driving, and the other ones is all the manufacturing or Industry 4.0 applications, as manufacturing lines and process and discrete industries are very expensive assets typically, and everything is done to prevent them to fall down. Overall, the potential is expected to be, according to the data we have, larger than $85 billion in a couple of years. So there is a lot of space for partners of AWS to build new applications, to embrace that technology, and to tap that market, ultimately helping customers to generate value.
You know, the one thing I would add on that too, again, is all you are here in the room and working with different customers, there's really no end in terms of opportunity kind of in the space. The amount of data being published in every segment seems to be going up, whether we're talking healthcare, life sciences, industrial, connected vehicles, the industrial segments, et cetera, et cetera. And again, I think it's becoming on you, and I think our customers are looking for the same thing, is people that really kind of help them kind of weave the story, help them kind of get the data. You know, as Joseph had showed up on the screen before, the majority of the data is actually, some of the data is being collected, but it's just sitting, if you will, in a data warehouse. There's no value to it. Is how do we kind of take that, push that down further? Or the other piece is maybe act on that data sooner and maybe store less in the cloud, if you will, and maybe just act on valid data where deep learning kind of happens in the cloud versus kind of on the edge. So again, I think it's really incumbent on the audience here, as you guys are looking at your practice, this is one of the areas that a lot of our customers are looking for help and guidance on.
Very good. So when we look at the use cases, we see three use cases that stand out. The one thing is computer vision, as I said, really analyzing what's within a picture, what's within a video stream, which objects are there. The second one is pattern recognition, basically signal processing. For example, in health monitoring situations, it needs to be ensured that, for example, the heart rates or other parameters of a patient are always tracked, given there is an internet connection or not. And the last one is robotics. Robotics is quite advanced technically, but it's kind of static. What we'll see in the future is more intelligent robots. Intelligence means AI, means machine learning, means need for a lot of processing. that will not always be there in the operation technology environment. So from time to time, there will be a need for additional computation in the cloud. On the other hand, robotics are very much real-time, so we need an edge device to really do the real-time control. So now that we also know what the addressable market is, I'd hand over to Joseph to go deeper into the architecture.
Thank you, Joseph.
Thank you.
So if we kind of take a look at what the traditional compute model kind of looks like today, and again, trying to get this kind of up there, very more of a simplified view in terms of an architecture, what it looks like. But at the end of the day, we do have our edge assets that are out there. They are actually publishing, they are connected, they're pushing information, if you will, maybe up through the data aggregation gateway, and then ultimately into the cloud. And that's kind of the notion of what we've seen and we've used and we've experienced today. When we kind of take a look, kind of at the stack, we're capturing data down below. There's a little bit of action taking place. I can see what the wind turbine generator's doing, but there's not a lot of intelligence kind of going on there. Sure, it's telling me how many kilowatts of energy are being created day to day, month to month, but at the end of the day, is there really any intelligence? I don't know for predictive maintenance. I don't know what my utilization is. There's a number of things that aren't happening there. The gateways or the routers or the switches, I use a number of terms interchangeably. They're aggregating maybe non-IP information, moving it onto the IP network, and really providing a bridge mechanism to actually get that information into the cloud itself in the digital domain. And then once there, of course, we can store it in any number of different ways, on-prem, off-prem. We do some data processing, and that's just where currently today where the machine learning and analytics capabilities is kind of taking place currently today. If we were to take a look at some of the companies that we kind of work with or some of the partners, if I was to say like something like maybe like a B-Square who does a lot of fleet equipment operations management. Their DataV platform is operating here. They're doing a lot of processing, machine learning, analytics. We look at what the likes of the Splunks are doing, maybe the C3IOs. And this is the model that we kind of see today. As we look at the edge compute model, we see some changes kind of taking place with respect to the overall architecture. I mean, fundamentally, it still looks the same, but what you'll notice is that the capabilities, what's happening gets pushed further down. And at the end of the day, right, it is edge processing, is what can we do kind of physically on the edge. So as we look at, kind of very down at the wind turbine generators, now we actually have that information for maybe doing some real-time storage, real-time processing of the information. Let's just say it's doing its thing, it's generating X amount of kilowatts of energy. Instead of sending all that information to the cloud, maybe just collects it for the day, and at the end of the day, it just says, I created this much energy, push that up. I processed everything local. Error codes, those sorts of things can maybe be done more local processing. And again, the deeper learning stuff kind of gets pushed up. We look at the data aggregation gateways. Now we see a lot more complex or more sophisticated in terms of the gateways that are out there, their ability to actually run edge services physically on there. We work with one of our partners, Machine Shop, and they have an edge processing that actually runs physically on the gateway to help kind of parse and process the information physically on the gateway itself. We're seeing a lot more work in the space. And the same thing with the hardware vendors. More capabilities, more memory storage, more capabilities kind of at the gateway itself. And again, that's kind of like the halfway stop. We can do a lot of processing there. As Joseph had talked earlier, there's things we can do at the gateway, the latency that we don't have to go maybe over the network, back to the cloud, get the answer back, helps in terms of the latency requirements. And of course, as we continue to still have the need to move that information, store long-term, up into the cloud, that's where all the deep learning is going to take place. All the new models are going to get, if you will, born, and a lot of that stuff can kind of get pushed down further to the, further back down to the edge. The other thing you see in the picture here is the purple gateway that's kind of in the middle. And in the purple gateway, I'm using the symbol as the gateway, but this could actually be like a PLC controller or any kind of sophisticated device now that's actually doing from edge to edge kind of communication down at the edge level. So we see a fundamentally architecture change. We see the elements becoming more sophisticated, more capabilities on the edge, the gateway, and of course the cloud is still serving the purpose. Joseph, you want to add anything? Or? So edge devices, right? So when we start to talk about this, and we went through kind of the notion kind of earlier what our edge device is. It is that ability to push that intelligence further down to the edge. For instance, in a traditional model, if we were pushing everything to the cloud, we might execute Lambda functions only in the cloud. Now we have the ability to actually execute Lambda functions closer to the edge and make decisions. This is important because of the fact that when we do lose connectivity, we don't have a connection to the cloud. How do we make a decision? With edge processing, we're now able to kind of do that. We can still execute Lambda functions and say, if I lose the connection to the cloud, this is what I want you to do. I want you to shut down in an orderly manner. I talked about, the permanent connection to the cloud. I mean, modern day communications are great. We all drive down the road with our cell phones. They all hang up on us for some apparent reason. We don't know why. Still, we need to plan for if we lose our communications, if we lose the connection to the cloud. Again, it's almost like investing. It's like having a diverse portfolio and where you invest in. Same thing here is where do you put your intelligence? I think you want to diversify. You put some on the edge, some on the gateway, and some on the cloud. And overall, I think you have a more how would I say, better architected, well-architected solution kind of moving forward. We talked about total cost of ownership. Do I really need to send everything to the cloud? It's a question you got to ask yourself. And again, I realize it's still day one. We still don't know maybe what information we should or we shouldn't send to the cloud. I always kind of caution customers when they're first starting on their journey, think about what data you have. You might not think something is important today, but 5 years from now, it may become important. Fact of the matter here is, again, think about the data, think about the valid data you need to send to the cloud. The easiest example I can give you is if we're doing temperature measurement and it's 72 degrees outside and I'm capturing 1 million reads of 72 degrees, do I really need to send that to the cloud over the network, over the LTE network? Probably not. That's a decision I can kind of make. But if you're looking at other parameters that are coming off your systems, think about what you're doing, what you're sending, where it needs to go, and where it needs to be processed. And again, at the end of the day, right, it's the edge is still fairly finite. A certain amount of capabilities, certain amount of computational horsepower, a certain amount of communication bandwidth, whereas the cloud is still infinitely scalable and can meet all your needs kind of moving forward. So again, architectural decisions you really kind of need to think about. So when Joseph and I were kind of talking kind of about the presentation and what we thought we could kind of share with you, there's a notion that we have these physical devices that are closer to the edge, that have more intelligence, that are doing kind of amazing things. But there's also a lot of other work kind of going underway where currently today there may be data centers in very specific locations. You can take a look where Amazon has all of our locations, or all our data centers, locations, and you'll know that we don't have one in every single state, in every single town, in every single country. The notion, though, of being able to act quickly on the information as close to where it's happening is one of the things that we're seeing. And another thing that we're starting to see more of is this whole notion around these regional or metro data centers. Smaller subsets of data centers located closer to where edge assets are located. And again, what we're trying to do here in terms of the conversation is for you, the partners, to really start to think of what's going on in this space. It's one thing to take a look at hardware devices and take a look at what's going on there. There might be another thing to look at this space is, could you be working with server manufacturers and creating these regional, regional data centers for doing edge processing closer to the network? We're seeing a lot of evolution in the space. Again, when you do so, again, every time you send that information, put it over the network, and when we were putting this together, I was trying to find, I had a slide at one point that showed the latency going from 2G all the way up to like 4G at the time, or LTE, and it was amazing, the amount of time, because going over a 2G network is a second worth of uptime, a second worth of downtime. Again, is that real-time processing? I don't know, you'd have to tell me based on your application. LTE was somewhere around 600 milliseconds. 5G is going to be even faster kind of moving forward. So again, every time you're going over the network, there's hops, there's latency that kind of adds to your equation. It's really incumbent on you to look at your application to see what model kind of fits best. And then we're seeing a little bit more in terms of the multi-axis edge compute. The Etsy organization is kind of looking at some of this stuff. And actually what we're seeing is that I'll use the term microserver for lack of a better term, but a smaller server actually located physically at the cell tower doing processing. And again, if you think about it from an autonomous vehicle perspective, the ability to be able to move all that information, do augmented reality, virtual reality, requires response times in the sub-milliseconds worth of time. If that extends out to 10s or 20s or 50s or hundreds of milliseconds of time, you get the Netflix effect where things are herky-jerky, it doesn't really work. So again, a lot of activity in the space. We'll continue to keep working, with partners like yourself. We'll be keen to learn from all of you here. What are you doing? Is there things you're offering that's differentiated in the space to kind of help you with your practice? Back to you, Joseph.
Very good, thank you. So let's now dig into a very concrete example, the industrial software space, where I can speak a bit about what we do with our partners. When we look at the whole chain, all products are first of all designed, then they're simulated, then production is designed, and then finally it goes into production, where first of all the basic assets are done. Here we see a body shop in automotive in this example, and then everything is simulated, is assembled, and then quality is tested. Finally, the product runs out of the factory. There has been a lot of innovation in the past around horizontal integration around these different enterprise types of applications. This is CAD systems, this is PLM systems, this is manufacturing execution systems. And this has done a lot of good. You always have a concrete representation of the product in any time and the production processes any time. Still, this is all IT. Means it is applications that reside in the data center, and there is the other side, which is the microcontrollers, all the small computers, all the PLCs that really do the hard work, which is referred to as OT. Those applications are typically programmed in totally different languages. They are kind of costly. Still, they enable to have real-time control, but they essentially are not built to really do a lot of things with the data that can be generated. And they are not very flexible in their programming model. With edge computing now, we have the theoretical, or we have the products, the tools to change that. And this is a huge opportunity for the partners to build new applications, to get rid of this OT, IT differentiation, to really think of what is the task I want to achieve, where in the horizontal stack I do want to do which compute, and optimize the applications for that. And I'll give you a very concrete example on what we've done. We work together with the University of Aachen in Germany, and with Boston Consulting Group. They have a real tech arm called Digital Ventures to build this thing based on a robotic example. The example is a glass handling use case, and I'll start a video and I'll talk over. I think we don't need the sound, and I'll just talk you over. So we've developed this with an example from a real glass handling production facility. The thing with automotive glazing is that it comes out hot of a baked oven, meaning that the shape is not 100% defined, because the cooling process, you can't fully control it. That means currently in such a factory, over time, the quality of the additional processes after the glass leaving the oven gets worse and worse and worse. What they do currently, they stop the whole thing, people walk into the facility, they reprogram the robots manually, doing all the handling, and then they restart. Summing it up for one factory per year, this is a waste of approximately 20 million euros, which is $25 million approximately. Multiplying that with a couple of factories around the world, this is a huge opportunity. And by the way, this is true for any type of currently automated systems. Once you have the insight, once you have done your predictions, your machine learning, it gets very manual. What you can see here, we build up a network. These robots are controlled by Raspberry Pis running AWS's Greengrass technology on it. These Raspberry Pis are $30 devices. And they're really controlling a 4 millisecond heartbeat every robot. What you just have seen, the first robot takes the shield and does a real-time measurement. So it gets a point cloud. That point cloud is set back to the cloud and then sent to that robot that you now see. And in the meantime, in the cloud, you can do machine learning, you can do optimization. This is the start of a priming action. Basically, something is added to that glass, and it can be now optimized for either speed or minimum use of what is added, like some glue, for example, or the minimum usage of the thing that adds the glue, or whatever. And you can do tests in your running production, and it will cost you close to nothing. Once that addition or that what has happened to the glass is done, we have a third station, just waiting for a robot to pick and place it. It is putting the glass to the station next to it. A camera makes a local snapshot, and there is a real machine learning use case algorithm executed at the edge. So the learning happens in the cloud. So whenever there is a new picture, it can be sent up to the cloud, but you can deplug it and the whole thing still will work. This is something that currently does not exist in the industry. We work closely with partners in the automation sector, but we also invite a lot other partners to help us to really bring that technology to the industrial space to help reduce the current waste that's there, because the systems are not as flexible as they could be. Good. As we speak, those robots are on the way to Las Vegas and hopefully tomorrow in the area, in the Pinion Alcove 1, level 1 in the IoT fair. This use case should be shown. So whoever wants to speak to the team that has built it up, that have experience working with our edge technology in a real IoT application, you're happily invited to go there from tomorrow on until end of the week. Thank you. Good.
You know, the other thing too to add on this is, as the robots in this particular location become well-versed and have learned, the ability to actually now to push that information down to the 150 other robots in other locations and other cities also is kind of the art of possible. So, again, as you kind of take a look at this, I mean, we might start with one, but again, you can actually kind of take that knowledge that was been garnered and gained and actually push that out further.
Very good.
Is it me? So let's talk about a couple different customer success stories. So Rio Tinto, global mining company. Within the mine itself, there are some connectivity challenges. I mean, these are typically, could be out in very remote areas. The use of, obviously, 10100 Ethernet in the mine with mobile assets is not an option. One of the cost drivers for Rio Tinto is the tires on these trucks, $40,000 per tire. Where they have a tendency to wear out is when there's bumps in the road. And again, these would be larger bumps that we see, well, maybe kind of the kind of bumps in a Minnesota highway, but here in the mine, actually fairly large bumps. One of the things that we did with those guys is we actually equipped the trucks physically themselves with sensors, had a data aggregation gateway on there, and we're doing pre-processing of a lot of that information live physically on the truck, publishing the validation data, the machine learning kind of moving forward up into the cloud. What ends up happening is, and what I probably should have showed on this is kind of showing you what a thermal heat map then looks like of the mine and where the trucks are riding, and it was green, amber, red, which can basically show where there are better places to fundamentally drive the truck, where there are kind of issues with respect to bumps on the road to kind of avoid it. And again, every one of those tires that they can save is money back kind of in their pockets. And again, I'm from Minnesota. I know there's a number of us here. Boy, I'd love this for potholes in Minnesota, because we go through tires and shock absorbers in the wintertime like nobody's business. Oops, sorry about that. Water quality. I think most of us are kind of concerned about water quality. Our folks at Frontier, Bright Wolf had worked with the folks at Pentier for water filtration systems. Again, you got to make sure you have that really good water for the beer, but the fish are also happy with it as well. And again, using local edge processing, make certain decisions, kind of moving forward. And again, if I get the story right here, especially like with some of the fish farming, in the ponds that they're at, they basically feed the fish, and they drop kind of pellets in through the water, and the fish kind of grab it. And for those of you who have a little aquarium at home, you put the fish food on top, the fish kind of go up. In these ponds, where a lot of stuff is located in the ocean, there might be like large orca whales or killer whales or other things on there that actually disrupt the fish and kind of make them nervous with respect to eating. So if they actually go ahead and dispense the food, and the fish are kind of freaked out, they won't eat. The stuff drops to the bottom, breaks down, and it degrades the water quality. So the ability to actually do processing local, et cetera, again, is paramount to this solution. So let's talk a little bit about maybe how we can help you as partners moving forward. So again, you're here at re:Invent. You're seeing each day X number of announcements kind of moving forward. Through the week, you'll see significant announcements with respect to services. As you see us continue to not only evolve in the cloud with services, but also kind of on the edge. You kind of see us playing both sides. So again, any questions you have, obviously reach out to your account executive that calls on you. You can certainly call the solutions architect. And again, for those of you in the partner organization, certainly reach out to myself, Joseph, and others here with respect to updates on any of the new services. Partner to partner partnering, no, I didn't stutter, is a very, very important part. Again, at an event like this, it's really critical. Still today, I can believe I can honestly say this on stage, that there isn't one company that does business transformation using IoT technology from edge to enterprise. It still takes an army of friends. There's a lot of you here in the room. Some people are ingredient providers, some of you are systems integrators. You all have specific domain knowledge. By all means, use the re:Invent to make sure you're capturing, who's here, what partners you can work with, who do you want to get introduced to, who can provide technology that maybe you don't have. Machine learning, data analytics would be a kind of one of those capabilities. You may not want to create that expertise in that domain. We do have partners that can kind of help you with that. Of course, the on-site training support, the classes, the certifications, the stuff you guys are really, really used to, by all means, take advantage of that. There will be a significant number of press releases this week. If you want to have the solutions architects come in, spend time with your engineers, value proposition in terms of the services, how do you use it, how do you integrate it, by all means, reach out to us. It's imperative that we teach you guys how to go ahead and use our services for our customers, because I can pretty much tell you that the customers who see this stuff are going to raise their hand. They're going to say, hey, Joseph and Joseph, who can help me kind of do this service, and this service? So again, we want to get as many of you trained so that we can push our customers to you guys to help them with their business transformation. We love to co-fund, innovate. And again, edge compute is a rapidly evolving space. We gave you some examples of where there's some evolution kind of taking place. If you think you have something unique that can actually drive specific workloads for our joint customers, raise your hand. We'll probably be interested, and we help you kind of co-fund that and develop that technology and help you kind of bring it to the market. Don't be afraid to raise your hand and say, hey, we would like to kind of do this with you guys. The co-marketing amplification of joint solutions. IoT is about putting solutions together. Every single one of our customers that we talk to wants a solution. They don't want necessarily an ingredient as part of it. They want the finished cake. They want Happy Birthday Joseph on it. They don't want to break eggs, flour, sugar, vanilla, et cetera, et cetera. We want to work with you guys to put together meaningful solutions to the marketplace. The Bright Wolf guys had helped with Pentair on the water solution. We can take some of that stuff, we can lather, rinse, repeat, take that to multiple customers. We want to have more and more of these examples next year to kind of highlight some of the stuff that, the amazing things that we're doing together. And again, all up the business, technical, sales, marketing, and everything help you to grow your business. Marketing Central, APN, Marketplace, all these assets are here for you to use. If you're unsure of how to take advantage of that stuff, send me an email, send us a text. We'll help you in terms of how to utilize those assets. It's a very, very self-service model. It's there to help you guys, but you have to take advantage of it. So key takeaways. We talked about earlier in the example that Joseph had provided in the oil and gas space. Most of the data is really not being used. It's just sitting there. It's just waiting to be acted upon. It's opportunity, right? Either people aren't acting on the data, so there's no opportunity, or nobody's acting on the data, so there is opportunity. I guess is the parable of the two shoe sales guys. The number of connected devices is only going to go higher. We have all seen this. I think we did a really good job in terms of not putting any specific numbers in this presentation that we've all heard 50 billion times. Okay, there's my poke on that one. Edge compute. We just see this being a very, very exciting and opportunistic space. Very much like the cloud was, we're seeing a lot of activity kind of going in the space and how to go ahead and actually derive business insights from that data closer to the edge. On Sunday night we announced some of the stuff that we were doing in the augmented virtual reality space. I don't know if anybody attended the Midnight Madness event over there, but there was like some amazing things in this space. This is an area that definitely I think you want to take a look at. It's kind of interesting. My daughter had, secretly sent to Santa Claus, like, I want this TV for my house. She says, they have it on Amazon, Dad, and oh, by the way, you can use your employee discount. Nothing like a lawyer selling you, right? So I'm looking at it, and it's like, oh, if you want to see the TV in your house, click here. And they actually have an augmented reality setup where you actually put something on the wall, kind of at your place, click this thing, loads this application on your phone, and you can actually see what the TV will look like in your house. This is going to fundamentally change how we buy anything that we use in our home, clothes, cars, et cetera, et cetera. There's an immense opportunity here. And again, a lot of that's going to require very, very strong edge processing capabilities to be able to do that. And with that, thank you.
Thank you.
You want to ask some questions?
Any questions? I think we still have 15 minutes time. We want to make sure that you get all questions addressed as far as we can answer them.
Nobody wants to know where the beer is at? What time?
Good.
Great. Thanks, everybody.
Thank you. Bye-bye.